You are listening to The Vocal Technologist. Spoken tech for your ears.
Happy Friday. It is February 6th, 2026. I'm your host, The Vocal Technologist, and welcome to another Tech Tuesday, which we are doing on a Friday.
Look, time is a flat circle in this industry. Tuesday, Friday, it's all just time until the next deployment.
That's a very grim way to start, but I get it. It's fair. We're running on async time. But honestly, looking at the stack of stuff we have for today, I think the delay was worth it. Usually we're drowning in headlines about the magic of AI, the models, the chatbots.
Art generators, yep.
But today, we're looking at the plumbing.
And the plumbing is starting to leak badly.
It's bursting. We're building these massive digital skyscrapers, these agentic workflows on foundations that were built 10 years ago for simple web apps. So our mission today is to cut through all that hype and look at the actual DevOps landscape right now in 2026.
Right. We're talking about how Agentic AI is shifting from a cool feature to a literal deal breaker.
And we're going to get into a $20 million argument for abandoning the cloud and just building your own server room.
Which sounds completely nuts, I know.
It does. And finally, we're going to talk about why your CI/CD pipeline, the very thing that's supposed to make your life easier, might be the reason you're so burned out.
It's a dense one. We're moving from can we build it to, I guess, can we survive running it?
Let's jump right in. The phrase of the year, Agentic AI. 6 months ago, I was impressed if a bot could write a poem that rhymed. Now I'm looking at this Developer's Guide to Agentic AI report, and the numbers are just aggressive.
Very aggressive, but they really reflect what we're all feeling. The one metric that stood out to me wasn't just adoption. It was the demand side.
You mean the 94% number?
Exactly. 94% of developers and product leaders say they would consider switching their SaaS vendors just to get better agentic functionality.
94%. That's everyone. That's not a market segment. That is the entire market.
It is. It tells us that agentic AI, and that means AI that doesn't just talk, but takes autonomous action to solve problems, it's no longer a nice to have.
It's a buying signal.
It's the whole decision. If your platform makes a user click 20 buttons and your competitor's platform just has an agent do it for them, you lose.
I think we have to clarify agentic here, though, because for the listener, this can get a little muddy. We're not talking about a chatbot sidebar that summarizes your emails.
No, that's generative AI. Think of it like this. Generative AI is an intern you can ask for ideas. Hey, draft an email for me.
Right.
Agentic AI is an employee. You give a goal. You say, fix this bug or optimize that database. And the agent has the permissions, the tools, and the logic to go do it, check its own work, and then report back.
That distinction is so crucial. It's the difference between help me write and do it for me.
Precisely. And the report backs this up. 85% of the people they talk to believe agentic AI is going to be table stakes within 3 years.
So if you don't have it, you're not even in the game.
You're not even in the conversation. But there's a huge gap between wanting it and actually shipping it. The report says 50% of teams are just stuck, waiting on security approvals.
And truthfully, they probably should be waiting.
Oh, absolutely.
You're giving a robot write access to your database. What could possibly go wrong?
Everything could go wrong. Security teams are the brakes on this car, and for a really good reason. The other bottleneck is just complexity. 44% of teams are bogged down just trying to integrate these things with their existing tools.
But some companies are starting to crack the code. We saw DigitalOcean launch OpenClaw this week.
Yeah, this is a smart move by them. They realized the hardest part of agentic AI isn't the model itself, it's the infrastructure hosting it. So OpenClaw is basically a one-click deployment for agentic workloads.
So they did the boring work so you don't have to.
Exactly. They removed the friction of how do I even secure this thing so developers can just focus on what do I want my agent to do.
Speaking of what agents can do, I have to ask you about this Databricks example. They built an American football defensive coordinator assistant. Now, I know we're tech people, but this sounded like my fantasy football league has gone wild.
It's a mouthful of a title, for sure, but the underlying tech is fascinating. It's a self-optimizing system.
How does that actually work? Because usually, if software is wrong, a human has to open a ticket, write a patch, deploy it, the whole 9 yards.
Well, in this case, they're using MLflow to create a feedback loop. The agent suggests a defensive scheme. A human expert, a real football mind, critiques it. No, the safety is too deep, or that blitz angle is all wrong.
Okay.
The system takes that natural language feedback and automatically refines its own system prompts.
Wait, so it's recoding its own instructions based on coaching.
It's encoding human expertise into the software without a developer touching the back end. That is the promise of Agentic AI. It evolves based on how you use it, not just on code updates.
That leads perfectly into the Datadog news. They just acquired Propolis, and this feels like the industrial version of that football coach.
It is. Propolis is focused on autonomous QA testing, and that's a sector that is just desperate for disruption.
Oh, yeah. Because manual testing is miserable. I think every single engineer has a scar from spending a weekend just clicking through a UI.
It's miserable and it's brittle. Historically, you write a script. Click button A, expect result B. But if the front-end team moves button A 2 pixels to the left,
The whole thing breaks. The classic element not found error.
Propolis changes that whole paradigm. It moves to outcome-based validation. It uses agents to explore the software like a real user would, using real production data patterns. It's basically AI testing AI.
Okay, so we've got agents writing code, agents testing code, agents coordinating football defenses. But here's the cold shower. All of this needs compute, and compute is expensive.
Incredibly expensive.
Right, so I want to pivot to our cloud versus reality check. For a decade, the mantra has just been, move to the cloud, it's cheaper, it's better, don't you dare buy a server. But there's a story out about Comma.ai that is basically taking that mantra and setting it on fire.
It's a $20 million bonfire. Comma.ai, they do autonomous driving tech. They needed a massive amount of compute for training their models, so they ran the numbers for doing it in the public cloud.
And the quote was, what, over $25 million?
North of $25 million. So George Hotz and the team, they decided to build their own cluster. They bought the hardware, they rented the space, paid for the electricity, total cost, about $5 million.
That's a $20 million difference. That's not a margin of error. That is a completely different business model.
It is. But, and I have to be the buzzkill here, we need to look at how they did it. Because they didn't just replicate AWS in a closet.
Right. I assume they didn't go out and buy enterprise-grade NVIDIA H100s for 40 grand a pop.
No. They used consumer-grade GPU servers, the kind of cards you might put in a really high-end gaming PC or maybe the workstation equivalents. They used simple, non-redundant storage. They basically just, hacked a supercomputer together.
They used Slurm for management, didn't they?
Yeah, they used Slurm, which is this workload manager you see in academic supercomputing. It's a command-line beast, not something you typically see in a sleek enterprise SaaS environment.
So the trade-off was, what? Reliability.
Reliability, convenience, redundancy, all of it. If a drive fails in the Comma.ai cluster, they might lose data. And they accepted that risk because for train or model, you can usually just checkpoint and resume. You don't need the 5 nines of uptime that AWS charges you a massive premium for.
So the lesson isn't just cloud is bad.
No, the lesson is don't pay for a Ferrari if you're driving laps on a dirt track. If you have a predictable, massive workload like training, the public cloud tax is exorbitant. If you're a startup needing to scale from 0 to 1 million users overnight, the cloud is still your answer.
It's about fitting the infrastructure to the workload. But speaking of infrastructure causing pain, can I just rant for a second?
By all means, the floor is yours.
Developer experience, specifically GitHub Actions.
Ah, the standard.
It is the standard. Everyone uses it because it's right there in the repo. But there's this fiery critique going around this week saying GitHub Actions is slowly killing engineering teams. And frankly, I feel seen.
What's the core complaint? The YAML.
It's the YAML fatigue. You spend 4 hours debugging white space errors just to deploy a hello world. The UI is slow. The permissions are opaque. It feels like we've just traded actual engineering for configuration management.
There's truth to that. YAML was never meant to be a programming language, yet we're using it to define really complex logic. It's brittle. You can't easily unit test a YAML file.
Right.
You have to commit it, push it, wait for the runner to pick it up, wait for it to fail, and then just guess why.
It's the commit, push, pray loop.
Exactly. And that's where tools like BuildKite are seeing a resurgence. Their philosophy is just different. They say, keep your logic in your code.
So instead of a massive YAML file, I'm just writing a script, like Python or something.
You're writing actual code. Ruby, Python, Bash, whatever. You own the infrastructure. You can run the pipeline locally to debug it before you even push. It treats the pipeline as software, not as a config file.
That sounds so much healthier. But this actually brings up a concept you flagged in the notes. We always talk about technical debt as the reason we're all miserable. Oh, the code is old, we have to refactor.
Right.
But you found an article that argues we're looking at the wrong enemy.
Yes. The argument is that technical debt is just a symptom. The real killer is cognitive load.
Break that down for me. What's the difference?
Okay, so technical debt, old libraries, messy functions, it's inert. It just sits there. It only hurts you if you have to touch it. Cognitive load is the mental effort required just to understand how to do your job.
So, like having to remember which of the 4 inconsistent environments I need to deploy to?
Correct. Or waiting 3 days for a security ticket approval and losing your flow.
Hmm.
Or wrestling with that brittle YAML file in GitHub Actions. That is all cognitive load.
It's the friction. It's the mental RAM you burn just trying to get to the actual coding part.
And the article argues that if you reduce the complexity of the process and the requirements, the technical debt often just resolves itself. If you lower the cognitive load, developers have the brain space to write better code in the first place.
That is profoundly validating. It's not that I'm a bad coder. It's that the system is designed to stress me out.
Well, let's not rule out the first option entirely.
Hey, I'm the host. You can't roast me on my own show. Okay, moving on. It would not be a Tech Tuesday without looking under the hood of Kubernetes. We're at version 1.35 now.
The ecosystem just marches on.
What's the headline feature here? What do I need to know so I don't look stupid in my next stand-up meeting?
The absolute game changer in 1.35 is in-place pod updates.
Which means?
Exactly.
Okay, so imagine you're running a massive AI model in a container. It takes 10 minutes just to load the model weights into the GPU memory. We're talking like 80 gigabytes of data moving across the bus.
That's a heavy startup cost. It's huge. In the past, if you wanted to give that container a little more CPU or RAM, Kubernetes would have to kill the pod, wiping out that entire memory state and start a fresh one. You'd take a 10-minute downtime hit just to resize the box.
That is unbelievably inefficient. It's like buying a new house because you wanted a bigger sofa.
It's a perfect analogy. With in-place updates, you can resize the resources of the pod without restarting the container. The process just keeps running. For AI workloads, for large databases, this is massive.
That's going to save so many headaches. What else caught your eye?
The node readiness controller. Think of this as a bouncer for your cluster.
You're not on the list. You can't come in.
Exactly that. In modern clusters, especially for AI, and nodes are complex. They need specific GPU drivers, specific network cards, specific firmware.
And if one of those is missing, the pod just crashes.
Right. The crash loop back-off nightmare. The node readiness controller lets you define a checklist. It ensures the node has everything, all the drivers, storage, configs, before it even allows a pod to be scheduled there. It keeps the club exclusive.
I love that. Stability through strictness. Now, before we leave the infrastructure world, I have to drop a scary stat on you. ChainGuard released a report about container security.
Oh, yeah. This one kept me up at night.
We always focus on the big images, right? Ubuntu, Alpine, and Jinx. But ChainGuard found that 98% of container CVEs, those nasty vulnerabilities, are lurking in the long-tail images.
It makes sense if you think about it. The top 20 images, the Ubuntus of the world, are scrutinized by thousands of security researchers. They get patched instantly. But that obscure image you pulled 3 years ago to resize JPEGs?
The one maintained by some guy in Nebraska.
Who hasn't touched it since 2023. That is where the rot is. The report emphasizes that you can't just secure your base OS. You have to scan and minimize every single dependency in your whole registry.
So spring cleaning isn't just for your house. Clean your registries, people.
And ideally, move to distroless images where you just strip out everything that isn't your application itself.
Okay, let's head into our final stretch.
Oh, it's
observability, or as I like to call it, why is everything broken and who can I blame?
I prefer how can we fix it quickly, but, your way is more dramatic.
Datadog is back in the mix here. They use something called LLM observability to debug their own tools. Now, is LLM observability just a buzzword, or is it a real thing?
Oh, it's real. Debugging a large language model is not like debugging code. Code is deterministic. I run it twice, I get the same error. LLMs are not.
They hallucinate. They drift.
Exactly. Datadog was trying to debug their natural language query agent, the thing that lets you ask questions about your data. It was failing, and debugging was taking hours because they couldn't see why the model made a specific choice.
So they use their own tool to trace the brain of the model.
Yes. LLM observability traces the chain of thought, the tokens, the tool usage, the latency per step. By visualizing that decision tree, they cut their debugging time from hours to minutes, a 20x reduction.
And that connects right back to cognitive load, doesn't it? If I can fix a bug in 5 minutes, I'm a happy engineer. If it takes 4 hours, I'm updating my LinkedIn profile.
Speaking of visualizing problems, CodeFresh has a new feature called Pipeline Performance Profiling.
This uses OpenTelemetry, right?
Yes. And this is applying observability to the build pipeline itself. Usually the CI/CD pipeline is just a black box. You just know it takes a long time.
It takes 20 minutes, so go get a coffee.
CodeFresh visualizes it so you can see, oh, the run test step is taking 15 minutes because it's downloading the entire internet every single time. Or this Docker build is caching poorly.
It turns the pipeline into a measurable product.
Which is vital for FinOps, because those CI/CD minutes cost real money.
Okay, one last quick hit before we wrap Cloudflare. They're doing something called vertical microfrontends.
This is for the front-end developers out there who are tired of monolithic builds.
Explain the vertical part for me.
So usually a microfrontend splits a page into widgets, a header, a sidebar. Vertical means splitting by feature. So the marketing team owns the landing page worker, the product team owns the dashboard worker.
And they're stitched together at the edge.
Yes, they're mapped to a single domain by Cloudflare. So to the user, it just looks like one site. But to the developers, they are completely independent apps. No more one typo and the CSS crashes the whole site.
Divide and conquer. I love it. Okay, we have covered a massive amount of ground today, from AI agents that coach football teams to hacking together a supercomputer with gaming GPUs.
Hopefully a well-ventilated supercomputer.
We can only hope. So as we look at all of this, the cost, the complexity, the agents, what's the synthesis?
Yeah.
What's the one thing the listener needs to take away from all this?
I think if I look at the trajectory from 2025 into 2026, the theme is just maturity.
Maturity.
Yeah. We're moving past the hype phase where we just throw money at AI and cloud. The questions are no longer, can we do this? The questions are, how do we host this AI without going bankrupt? And is our CI/CD process actually helping us, or is it just creating misery?
It's about intentionality.
Exactly. It's about realizing that cloud isn't the default answer anymore. Sometimes you build a server. It's realizing that GitHub Actions isn't the only way to deploy. It's taking control back from the chaos.
Taking control back. I like that. And I want to leave you, the listener, with a final thought to mull over this weekend. Go back to that concept of cognitive load.
It's the most important metric you aren't tracking.
Look at your team. Look at yourself. If you are feeling burnt out, ask yourself, is it really the code? Is the variable names in the old libraries? Or is it the wasteful requirements and the process complexity you've wrapped around the work? Are you tired of building, or are you just tired of all the hoop jumping?
Solve the process, and the code gets easier.
On that note, I'm the vocal technologist.
And I'm ready to close my laptop.
Wishing you a low latency, bug-free weekend. We will see you on the next deep dive.
Goodbye, everyone.
Spoken Tech for your ears.